Tonight I have the real joy of introducing one of my dear colleagues, Ashby Kinch from the English department. I remember when Ashley first was invited here, and I think I was invited for a lunch or somewhere out at the Mustard Seed, and it was great because he was going to talk about old things. He studies old things, and my old things are somewhat older than his, but still you take it the way you can get it at this university, right? Ashby is a medievalist. He studies then a period which a lot of us might think of as the Dark Ages. That's the way they used to talk about it when I was young, back in the Dark Ages. But because of people like Ashby and many, many other scholars, the Middle Ages have become brighter and brighter and brighter for us as we go along through the years. And so Ashby has begun his studies in the medieval period with an interest in literature, as so many of us do, and then has branched out into all kinds of art and culture, the culture of translation, which is really an interesting area in its own. So Ashby has a whole lot of interesting academic interests with which he's lived for several years. And I think that the story which he tells, the reference which he makes in the program, really sort of underlines the way I feel about our various research and scholarly interest. That is, Ashby's here tonight because, not because he's a brain scientist, although he's smart enough to be one. Not because he's a brain scientist, but because 10 years ago, somebody who's in this audience was born, and that was Ashby's first child, and he began to really wonder about what goes on with the brain and how does it develop, and I really think that our scholarly questions are things which come from the people we are. And this is one good example of that. So Ashby's going to come to talk to us tonight, and as you can tell, we had a little music, we had a little art to go along the way. So Ashby, I'm going to let you come up in just 1 second. I want to make sure everybody's phones are turned off. I want to announce that we don't yet have the MCAT schedule, but we will have it for you for next week. So if you've had to miss any of these lectures, we'll be able to get you a schedule, and you'll be able to watch them on MCAT. And I think they're usually shown 2 or 3 times. So that's good. So with that, Ashby, everybody's settled into their seats now. We're ready. Okay, Ashby Kinch.
Can you guys hear me? You notice the change in the microphone. I've got the McDonald's earpiece on. It's actually quite nice. It's very light. Thank you so much for coming. And I think, each speaker has thanked a group of people, and the thank yous have mostly run out. But one thank you is, thanks to the audience. Thanks for those of you who have persisted through the whole series. It's really been a remarkable series. And I've been at the back taking notes furiously and studiously, learning quite a bit each night. And it's a little daunting. I'm a little bit flummoxed today to be on the other side of this and to talk about my very, very recent interest of mine. But I do have to say a special thank you to Chris Comer, the dean. Going all the way back to when he visited campus as a candidate, I had a great conversation with him then about Samir Zeki and his book Intervention, which when he left, I immediately started reading it, went down to the library, picked it out, and that's kind of kicked off a more intense wave of interest in this area of neuroscience and the brain. And of course, he has really been a great dean in terms of offering leadership on the importance of interdisciplinarity. And each speaker has kind of had their little soapbox, and that's one of the soapboxes I really want to focus on tonight. The real deep importance of this kind of cross-disciplinary collaboration. There's kind of weak interdisciplinarity and there's strong interdisciplinarity. And the weak interdisciplinary are where real closely adjacent fields are working with one another. But I hope tonight this is an example of strong interdisciplinarity, although I'm going to give disclaimers like John gave about my lack of research expertise, obviously, in neuroscience. I also have to say a couple disclaimers about the images you saw. That is a kind of longer cycle of images. I won't use half of those in tonight's presentation. In fact, as I had to kind of make some severe cuts just this late afternoon, realizing, I don't want to bore you to death. So you won't see as many Chuck Close photographs and paintings as you saw during the preview. You also won't see this guy, the little chubster over here, Geoffrey Chaucer. He's, one of the real reasons why I do what I do. I think he's the most amazing author that's ever written. I've dedicated much of my intellectual and labor to him over the last 20 years, but he didn't make the cut. Part of the reason was I wanted to try out something different. I talked about Chaucer last summer in Italy, a paper called The Neuroplastic Aesthetics of Chaucer's House of Fame. My wife saw that paper, and we're always trying to impress our wives, right? So I had to present new material tonight. I couldn't repeat, what I had done. But I left him on the title slide just because I think it's so funny with his hands poking the brain there. So I left him in there. So I'm going to get to some of my disclaimers right off the bat, if this works. My disclaimers, here they are. I've never operated on a brain, at least surgically. I've never experimented with a neuron, at least manually, and I've never treated anybody for their depression, anxiety, or behavioral problems, except my family. And really, honestly, they're really doing the treatment most of the time. They're treating me. In fact, they are, as I said in the program, my two children, Shelby and Griffin, they're back there in the back of the room. They really are the origin of my interest in the brain. I don't know if any of you have read this book, but I read it when Amy was pregnant with Shelby. It came out in 1999. I read it in 2000. And some really important ideas came out of that book for me. In many senses, they weren't new ideas. They were things that I kind of felt already, but the book confirmed them in a really important way. And that first idea that humans are intensely social creatures, and that emotional attachment is essential to brain development. Not just essential in a kind of psychological way, but essential in a physical way. Siegel's work, he did trauma studies, studies of children who had experienced childhood traumas, and he was able to prove quite definitively that these traumas, these emotional and psychological traumas, inhibited their brain development. It's a very, very important idea. Of course, the pop cultural myths of hyperstimulus of children, they probably do push too far. And we all remember the 90s, there was kind of craze, the decade of the brain. There was a craze for all the different ways you can improve your children's future SAT scores, But we can't underestimate the importance of, oops, too far there, rich mental environments. That's the last kid slide. John got a couple in. I figured, I could get a couple in too. But there they are, traipsing around France. Rich mental environments, such an important concept. So a few key questions have been guiding my thinking about culture and the brain. The first one is, what can recent research on the brain tell us about the experience of reading literature and viewing art? How specifically can it help us understand the art and literature produced by people who lived and died centuries ago in what we often presume to be very different neurological environments? This is a kind of emerging field called cognitive historicism. And for those of us who study old things, like Linda, this is a really important premise, right? This is a really important way of us thinking about the bridges we have to the past through the brain. And then this third question, what new ideas emerge when we think about art in terms of its impact on the brain? Are artists attuned to brain processes intuitively? That's in my title. Even when they lack the sophisticated tools of analysis, fMRIs, PET scans, MEGs, and a sharpened scientific understanding. So in general, I refer to this as the intuitive hypothesis. So these are my major assumptions. Art and literature are essential biological equipment. This is an idea I'm borrowing from evolutionary biology and sociobiology. Art and literature occur in the brain. And then finally, brains have an uncanny and essential ability to engage in communication outside the temporal pressure of the individual moment. So I'm going to talk a little bit about different approaches that one could take and are being taken to studying the brain and culture. The first is you'd study contemporary artists who are working with neuroscientific ideas explicitly. That is, contemporary artists who are thinking about neuroscience, adapting it in some way in their art. And you saw some images during the slide preview of, I'm going to show them again later, of a visual artist who's doing that. And I'm going to talk about a couple of literary artists who are doing that as well. You can read the work of scientists who are extending their research approaches into interpretations of art and literature. I'm going to talk about two major figures in that area, Samir Zeki and V.S. Ramachandran. Does that name V.S. Ramachandran, is that familiar to you? mean, you guys been heard that? His name has kind of gotten out there in the public a little bit. He's an eloquent writer. He's very clever, very, very interested in art and literature. So he's been writing on these topics quite a bit. And then the third is engage in collaborative projects between scientists and humanists, attempting to build conceptual and experimental bridges between the disciplines. I'm going to talk about a couple of those. And then conduct independent research and application of neuroscientific research to art and literature. And again, I'm dabbling in this. This is very, very new material. And I thought I'd give a couple of examples in the second half of the lecture of ideas that have sprung up for me in reinterpreting works that I had worked with before. So, off we go. Neuroscientific approaches to art, Samir Zeki. His research specialty is analysis of the visual cortex. And a particular goal of his is to map the visual cortex. He's been doing this work for 30 years. And particularly to focus on specialized neurons that respond to a specific kind of visual input regardless of the object. And so here's a few examples that they've mapped out. Orientation selectivity, right? We found specific cells in the visual cortex that only respond to horizontal lines and only respond to vertical lines. Specific cells that respond to movement, color, and shape or outline. So his work, his lab is mapping the visual cortex and taking this modular approach to show these specialized cell responses. His intellectual interest in terms of how this relates to art is the idea of perceptual constants. How does the brain abstract from all of the dizzying variety of visual input that we get? How does it abstract core perceptual images that we then have conscious awareness of? Now, V.S. Ramachandran, he's famous for his work on the phantom limb syndrome, and particularly with a treatment of the phantom limb syndrome using, you guys know what phantom limb syndrome is? Okay. Using mirrors, mirrors that tricks the brain into seeing a mirror motion as though it's taking place and slowly taking the pain away, that the phantom pain that existed in the limb, by tricking the brain into seeing a normally functioning limb. It's a very, very simple treatment, costs almost nothing, and it's one of those intuitive insights that are just brilliant scientific breakthrough. And his lab in general does very creative experiments focused on uncommon neurological conditions. They've worked on anosognosia, which is the inability to recognize a neural deficit that you have. So in a couple cases he's looked at, people were unable to move their arm, but if you asked them to move their arm, they'd say, I don't feel like it right now. Or, oh, I did move my arm, didn't you see it? So their left hemisphere of their brain is making up a story, confabulating in the lexicon, making up a story to explain an underlying neurological deficit that's very real. Another condition is called blind sight. It's very similar to anosognosia. People can actually register visual input in their brain, but there are two paths that visual input takes in the brain. One is an old path that goes down into the midbrain, the superior colliculus, and one goes up into the visual cortex, and it results in perceptual awareness. Well, in blind sight, the patients don't have perceptual awareness, but they still can see. And the way they test that is people can reach out and grab objects right in front of them, even though they can't perceive the visual input or the visual data. And then the third is synesthesia, and we'll come back to that a little bit later. But the big question here is, what can we learn about the brain by looking at these uncommon processes, these rare conditions? Now, collaborative projects, there's some really interesting stuff going on. The art historian David Friedberg, he's written a really important book in my field called The Power of Images, about late medieval icons and worship of icons. He's teamed up with a neuroscientist named Vittorio Galeazzi, Italian, who works on the mirror neuron system. How many of you have heard of the mirror neuron system? It's been in the press a lot. That's why I thought maybe you might have heard about it. So Galeazzi and his lab, his other Italian colleagues, are trying to extend their understanding of the mirror neuron into social emotions like empathy. And the mirror neuron studies are again, fairly straightforward. They involve studies of monkeys in which the monkey sees another monkey acting in some way, picking up an object. and they register the activity in the brain of the monkey who's watching. And it turns out the brain activity of the monkey watching is roughly the same as the activity of the monkey doing the action. So they've posited this idea of the mirror neuron system from this research, and they think they've localized in the action recognition system. I'm going to show you an image here that, here it is, yeah. In their article on this, Friedberg and Galeazzi bring up this very, very powerful image. It's Caravaggio's The Incredulity of St. Thomas. And they talk about the way in which an image like this evokes empathy, but in particular ways involving the physical touch of the hand and the body. And so the idea is Friedberg and Galeazzi are kind of working out whether or not art can kind of promote a virtual form of engaging the mirror neuron system. Now another project, and this one's much closer to my own work, involves neuroscientist Yadin Dudai and a medievalist named Mary Carruthers, who works on medieval monastic locational memory systems. That is, the ways in which monks memorize long, long, long passages of the Bible. And I have to thank Dean Comer for this reference as well. He sent this article to me. They reproduced this famous, in this essay, they reproduced this famous image, famous among medievalists. It's a late 14th century Cambridge brain diagram. It's quite beautiful. It's a really striking image. The more you look at it, really that red is so rich. But what it is a map of the medieval brain as understood through what's called medieval faculty psychology. Each of the circles represents a different faculty. The front of the brain represents what's called the sensus communis, which is the place in the brain where all sensory information comes in. The next vesicle represents what's called the vis imaginativa, the imaginative power, the image-making power, we would say. And then the two circles next to it, you can see little branches breaking off of it, represent, the upper one represents the power of judgment, the vis estimativa, and the one below it is the vis formalis, the formal power. And so these are the cognitive powers. You see something, you make it into an image, and then you make a judgment about it, or you do further thinking about it, right? The higher one is the simple form, the lower one is the more complicated form. And this is one of my favorite images too because of this little guy. He's described in the text, it kind of looks to me like a lizard, but he's described in the text as corpus ad similitudinem vermis, a body in the similitude of a worm, or in the shape of a worm. Now, I don't want anyone to walk away from this talk thinking medieval faculty psychologists believe worms move things around in the brain. The artist is very, he takes liberty because the text actually quite clearly explains that what they're describing is a part of the brain that kind of looks like a worm. And so the artist knew enough Latin to know what they were saying, but this is not, in other words, this is not a physiological mechanism. But what's happening is here, formal thought, I should have been using the pointer all along, but formal thought is being moved by this worm into the memory. And this is the memory at the back of the brain. Now, what Dudai and Carruthers say about this image is what interests me, less so than its accuracy or anything like that. It's our aim to promote, it is not our aim to promote the erroneous brain biology of times past, but we do wish to revitalize the intuition and insight of scholars who didn't have powerful tools, such as functional magnetic resonance imaging, and yet still wisely contemplated the global picture of the human mind. Their insights belong not only to the history of ideas, but also are relevant to neuroscience today. So it's the intuitive hypothesis that interests me, and this is another quote from Zecchi on that same score. He says, I hold the somewhat unusual view that artists are in some sense neurologists, studying the brain with techniques that are unique to them, but studying unknowingly the brain and its organization nonetheless. Joan Allaire's book, Proust Was a Neuroscientist. Does anyone know this one, this title, Proust Was a Neuroscientist? It's a great book, it's really breezy, fun. He studies Proust, obviously, but he also studies cooking and music. And his interest is in, again, the way that artists have a kind of intuitive way of understanding the complexities of brain processes and interacting with them specifically with their art form, whatever their chosen art form is. So the contemporary artists I thought I might talk about, and I may really breeze quickly through these and just, we can come back to them if those of you are interested in them. But the British novelist Ian McEwan wrote a novel called Saturday, quite an excellent novel, set on one day in the life of a neurosurgeon. Henry Perrone is the main character, and it kind of tracks through his mind as he reflects on his world. A couple of big events happen, and uses the lens of his neuroscientific training as a way of understanding what's going on around him. The American poet Cole Swinson wrote an incredible book of poems, I think, called Such Rich Hour, and I've written a couple of essays on that, on this collection of poems. And what interests me is that she's made some artist statements, oh, here we go, pointing out how important Samir Zeki's work is to her own conception of, especially how the visual brain works, as you can see in this quote, training us to see constants and to gradually develop overall perceptual continuity. In the evolution of both the species and the individual, the creation and perception of art has reinforced the recognition of meaningful patterns and helped suppress distraction by ones that are not. In this next slide, this is an image from a 15th century manuscript called Le Très Riche Oeuvre de Jean-Duc de Berry, who's an early 15th century patron of art. And her whole collection, Such Rich Hour, is based on poems that are responding to the visual image that you see here. And I'm not going to go deeply into it, but we can come back to this in Q&A as well. But what's beautiful about this image, she says in that quote later on, she says, she thinks visual rhythm and poetic rhythm might be part of the same brain process, and she's interested in stimulating them both. If you look at this image, you can see the rhythm, visual rhythm that she's responding to here. Obviously, the women stacking hay in the foreground, which of course requires a certain motor sensory rhythm to stay in coordination, and then the men cutting the hay here. And her, I couldn't find the quote off the top of my head, but I'll try to do it off the top of my head. Sickle one and scythe two and reap and shear and plow. That's the opening line. And you can hear in that her attempt in poetry to imitate the rhythm she's seeing visually here. It's really quite wonderful. This is the image that, and I'm not going to talk about this one hardly at all because I think I heard quite a bit of murmuring when this was going on. I think you all recognize the image after seeing it a few times, yes? And what's interesting, of course, is, well, this is the fact you may not have. The image in the background is made up of threads of spool, 20,736 threads of spool. So rather than being a, again, representational form that imitates Da Vinci, she moves the image into a slightly different form, lays it out inverted, of course, because that's the way your retina sees images, right? That is, it inverts them, and your brain has to perceptually flip them back over in order to see them accurately. And in every one of her works, she includes a little seeing eye that you can walk up to, so you see the image from afar. As you walk up, of course, the closer you get, the more distorted the spools look. That is, the closer you are to the artwork and the more you see its material underpinnings, the less clear the image is, but yet the crystal eye is there for you to see it in its flipped order, resolving the image. And again, in her artist statement, she's written quite a bit about how she's been influenced by her reading in neuroscience, particularly the brain's tendency to send expectation, images of expectation, what the brain expects to see, and then seek confirmation through the senses back. It's called the feed-forward, feedback mechanism. There we go. And then another example is you saw all of those portraits from the famous portrait artist Chuck Close, who's a prosopagnogic. That is, he has this relatively rare, although not as rare as you think, 2.5% of the population. It's quite a large number for a disorder like this. He's prosopagnogic. And the question that pops out of this is, how is his artistic technique affected by his neurological condition? How does he overcome it? And what do we learn about the human face from engaging with his art? That to me is the interesting question. And one of the interesting facts is that studies have shown prosopagnogics tend to develop an ability to recognize faces from their left hemisphere rather than their right. If you don't have this condition, you have a very quick and efficient way of recognizing faces using your right hemisphere. Prosopagnogics use their left hemisphere, and they build the representation up from really small details. And if you look closely at Chuck Close's pictures, many of which are 10 or 12 feet tall. They're massively big. You can see that that's in fact what he's done. He's built up representations. This is a self-portrait, and you can see on the right a section from the eye. This one I think is 10 feet tall. So that's a kind of interesting way of sort of thinking about a neurological deficit that spurs a whole different kind of artistic creativity and asks us to ask different questions about the human face than we otherwise might ask. Of course, the face is a very important object of biology and culture. The evolutionary biology of face recognition is very, very powerful. You know, we're a social animal, and seeing and responding to other people, seeing their emotions and being able to quickly on the fly adapt to their emotions, extremely important adaptation. A lot of our emotion processing takes place in engagement with the face, and the eyes are absolutely essential to this. We all know this, I think, intuitively, and culturally we have this long tradition of thinking about metaphors of the eye and engagement with other people's eyes as elements of our inner subjective understanding. People have cold eyes, or they have warm eyes. People have penetrating gazes, or they have impenetrable eyes, right? And these are all metaphors, right? These are all deep, they're so deeply embedded we don't even see them as metaphors anymore, but they all are. They're haptic metaphors, cold and hot, right? Now, I came across this really interesting study, a guy named Christopher Tyler. The study's called the Covert Eye Centering Principle in Classical Portraiture. He studied 282 portrait artists over a 600-year period of time to see if he could sort of find an implicit principle of eye centering. And what he found is very interesting. There was no explicit discussion in the artistic manuals. Nothing saying, make sure one of the two eyes is at the vertical midpoint, right? And yet, by a vast majority, they were. That is, he found vast majority of portraiture, not all by any stretch of the imagination, but a vast majority, the most centered eye ran roughly through the midline of the painting. So this is just kind of an interesting, kind of different approach an art historian wouldn't take, right? This guy studies the retina. We, of course, read emotions in the face, and in doing reading on, to kind of bone up a little bit on this, I found this really interesting fact, which I thought was really important to stuff that I look at from the late medieval period. 80% of women, both left and right-handed, cradle their babies in their arms to the left. And what it turns out is that men, prior to becoming fathers, don't have a preference. They don't have a left or right preference. But after they become fathers, left, in the exact same numbers, roughly, as women. So why? Well, the left visual field, that is the left eye, is the domain of the right hemisphere. And there's a major, major lateralized difference in the processing of emotion. That is, the right hemisphere is very dominant in the processing of emotion. And this has really specific application to different parts of the face, so that the right hemisphere focuses on the eyes, particularly on tears, which do not typically engage the left hemisphere. Left hemisphere focuses on the mouth. And part of the reason for that is, what comes out of the mouth? Language. And the language is the domain of the left hemisphere. So the left hemisphere, through the right eye, I should be saying here, focuses on the mouth. The left eye focuses on the eyes. And typically, there is very little or limited emotional information transmitted through the mouth. Now, I thought, that's kind of interesting. I'm going to go back and look at some portraits of the Virgin. This is in the area of my specialty. In the late 13th and early 14th century, there's an artistic revolution, which is usually described as the revolution of naturalism. A movement from the Byzantine forms of iconic portraits of the Virgin, where she's very static, often seated on a throne, to a more naturalized expression of soft emotion in the face, kind of gentle features, interactive relationship with the Christ child. And some of the major figures in this revolution, Cimabue, Duccio in Siena, Giotto in Florence. I'm going to show some slides, and you saw them in the preview, to just kind of show you this happen. We being my wife Amy and I, saw this incredible image this summer in Siena. It is mesmerizing. It's one of those images, you stand in front of it and you can't believe how much it just sucks you in. It's like a black hole of conscious attention. But it's not aesthetically like what we're used to in art, right? This is a little alienating from the standpoint of our artistic standards. She's called the Madonna degli Occhi Grossi, which means the Madonna of the big eyes, right? And look at her eyes. They're massive. But that's part of what makes her so mesmerizing when you see her in person. And this is the iconic style. Frontal view of the Virgin in a majestic setting with the angels hovering above her, and an iconic engagement with you. You're supposed to feel like you're in the presence of a deity when you look at an image like this. When you look at an image, just one generation later, this is Duccio's Rucellai Madonna, and I'm sorry about the darkness of these images, I wish they were better. You start seeing the cock of her head, the slight tilt of her neck, the gentle features, her eyes starting to take on a more natural, quote-unquote, shape. Stop moving very fast. There we go. Simone Martini. And then here I've put the two next to one another so you can kind of compare them visually, and you can just see some of these effects going on. I especially am interested in the image on the right from the standpoint of the Christ child's engagement. You see that eye? Now, this is going to become more important when we go to the next image. This is a very famous late medieval image called the Weeping Madonna. Has anyone seen this? It's in the Art Institute of Chicago. It's absolutely breathtaking and emotionally very, very powerful image. And the reason it's revolutionary in Western art is that her sadness, this is a break from the images we've just looked at, where she's placid and content. Obviously, this is Mary contemplating the death of her son. So it's emotionally appropriate for her to be in this state of emotion. But it's revolutionary to see it in visual form. It hasn't shown up powerfully prior to the 15th century. So Derek Boot's workshop produced this image. And I'm going to bring it in a little closer here because I think it illustrates some very interesting principles, like we were just discussing, involving the right hemisphere and the left hemisphere, and the relatively minimal emotion conveyed by the mouth. There's the mouth. I'm brand new at these whole dynamic slides. This is a lot of fun for me. There's the mouth. Left hemisphere, emotional link, but limited emotional information. Look how small that mouth is. Look how contracted it is. It's closed. There we go. Isn't this fun? I love this. There we go. There's the eye. Here's the right eye engaging us on the left. You see the tears just barely forming right at the lid. Really meticulous attention to this precise moment in time. And of course, the right eye is engaging the left eye of the observer, and therefore promoting right hemisphere activation. And also in the portrait, it is the more centered eye. And then, of course, the recessive eye, which I think is equally interesting in a way, that is that left eye, which is engaging with the right eye of the observer, is promoting left hemisphere activation. But it's in a recessive shadow. We have to work harder to get to that eye. And I think part of the work involved is part of the emotional context here. She is slightly removed from us. She doesn't look at us. She looks down and away. And so we connect immediately with the emotion, but then we have to work to connect with her. She is resisting connection. There it is up close. It's really scary when you blow that one up. There it goes. All right. Now, I was going to segue into Chaucer's literary portraiture here. That was the next move I was going to make, to talk about the general prologue to the Canterbury Tales, in which he depicts these absolutely marvelously detailed portraits of the pilgrims that he joins on pilgrimage. And there in the middle is the prioress, and there on the right is the miller from the Ellesmere manuscript. But I decided not to because I think it was going to take us down. It's fascinating material, but it was going to take us down a more complicated road. And I thought we also needed to talk about some other issues involving reading. So by Chaucer, And we could talk about that in Q&A as well, if you're interested. When we read, we use multiple brain regions. And I'm getting most of my understanding of this from a really fantastic book called The Proust and the Squid, Proust and the Squid. In it, Wolf is her name, she discusses how complex the reading process is. We have to use visual processing areas in the occipital temporal region. We have to use Broca's area in the ventral frontal region of the left hemisphere. We have to use multiple elements of sound and sensation in the temporal parietal region, which is a multifunction region spanning the upper temporal lobes and the lower parietal lobes. And there's really interesting analysis in this book of the differences between the logosyllabary languages like Chinese and Japanese, which show greater bihemispheric activation, whereas readers of Western languages tend to be dominated by the left hemisphere. So our language system promotes efficiency in the visual processing of words. It promotes a quick, efficient visual engagement with the word. And you guys have experienced this when you're reading. You know how fast you can move through language. Whereas Chinese and Japanese, the characters, because they have more complicated visual information on the page, require much more active bihemispheric work by the brain to make sense of the images, of the words. Now, part of this, of course, has to do with studies of reading development. Early readers also have more active bihemispheric activation. Early readers vocalize more. That is, as they're learning to read, they tend to read out loud more. And therefore, they're integrating phonology with visual, orthographic, and semantic processes. Reading aloud activates the somatomotor and sensory motor areas in both hemispheres, and that process is bypassed when readers become more fluent. That is, the more fluent you become, the less you vocalize, the less you're using your mouth, and so you're decreasing your motor sensory activation because you're not using as many muscles to do the work of reading. So become more fluent, more efficient. But part of what I'm going to argue, actually I will argue this for a second on this previous slide, part of what I'm going to argue is that poetry is attempting to get us back to a more active bihemispheric reading process. Part of what poetry is attempting to do is to break through the efficiency with which we read and try to teach us to hear language and say language and feel language a little bit more intensely than we typically would when reading the newspaper. And I'm going to do a little experiment with you guys. Brief experiment matching two made-up words. I'm sorry for this, but you're going to have to say them out loud. Booba and Kiki. And you're going to have to match them with two visual shapes. So let's hear it. Booba. 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 Kiki. 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 All right. Now, which one goes with which shape? I'm going to show you the image. And unfortunately, I'm going to have to, because it's a big group, I want you to raise your hand if you think the one I point to is Kiki. All right. Booba. Say it again. Booba. Kiki. Kiki. All right. Here we go. Is this Kiki? Raise your hand. Yes. Any boobas in the crowd? Any boobas for that sound? Yeah, the left one's Kiki, right? And this one's clearly booba. Clearly, right? I mean, there's no doubt about it. It turns out 95 to 98% of subjects choose Kiki for the figure on the left and booba for the figure on the right. And what's really interesting about this study, this comes out of Ramachandran's lab, is he did it with Tamil speakers, he did it with Spanish speakers, right? And he moved across language groups. Turns out it doesn't matter. It doesn't change the results, right? So what's going on there? Well, part of it is when you say those words aloud, you're having to shape your mouth, right? Boo-ba. The rounding of your lips as you say that word matches the visual data your eyes are giving you for the rounding of that shape. Just as Kiki matches visually the shape that your mouth makes when you say those words. So, angular gyrus, is it the master of metaphor? There seems like a lot of action going around the angular gyrus in neuroscientific research. It's located in the parietal lobe near the superior edge of the temporal lobe. Ramachandran did a study of right-handed patients with damage to their right angular gyrus. And what he found is very interesting. There's intact language function. These people speak perfectly fine. They understand English. They're perfectly fluent with their language. But they can't process metaphors. They're given a metaphor, the only understanding they have of it is literal. They cannot process and understand a simple metaphor. And also these same people have an inability to recognize the Buba Kiki effect. 10% of them judge correctly, as you guys just judged instantaneously. So they have a deficit in the connection between visual stimuli and I should have written oral language. That's the important thing here, the oral pronunciation. So language is multimodal. It's intrinsically multimodal. It's multisensory. That is, as you speak, and as you're engaged in conversation, or even as you read, it's linking visual, oral, and haptic systems. The motor sensory map, the somatotopic map that Dean Comer showed us in the first lecture, it's activated very, very actively via connections between and among all of our different sensory processes. Now, synesthesia is a very specific condition which involves the cross-modal linking of one sense impression with another. Poets have been doing it, of course, for centuries, but what I'm talking about here is the neurological condition. Its common form is when people perceive numbers as having a color. Well, Ramachandran did a study, and it turns out the number area of the brain is directly adjacent to area V4, which processes color. So the speculation is that they're cross-wiring. And some of that same cross-wiring, Ramachandran in his lab have found in phantom limb syndrome. People are touched on their cheek, and they experience it as an arm sensation and vice versa. Because in that somatotopic map, the arm and the fingers are adjacent to the face in that particular map. I should have brought that image in. That would have been helpful for you here. Sorry about that. It's a little abstract when you say it that way. Well, it turns out artists and writers are 7 times more likely to be synesthetes. Metaphor is a common mode of promoting cross-modal integration of sensory perceptions. We do it all the time. We have all these common expressions: sharp odor, loud shirt, and this one's for my wife, yummy clothing. You guys use that one? It seems like women use this one more than men, but the idea that your clothing physically touching your body has a taste, somehow. So what I'm interested in as somebody who studies literature is not the kind of simple reactive mechanisms of the brain, but rather the way art and literature engage us in a cognitive process. And Michael Baxendall calls this the cognitive itch, right? What does a work of art do that kind of creates a cognitive itch in us that makes us want to learn more, think more, do more with it? And then in literary studies, we have a Russian theorist named Viktor Shklovsky. I love saying his name. Sounds like a sandwich shop. And his concept is ostranye in Russian, meaning something like estrangement or defamiliarization. And what I'm interested in is how does that experience, that affect our experience of great art? What are the abilities of an artist to renew our perception by doing something new or different or strange in the representation of it? To break through, I guess what I'm saying, the efficiency processes that the brain might more naturally be inclined towards. So literariness might in some ways be redefined as maximal cognitive load. What makes a work of art, a great work of literature, is that it places greater demand on the brain than ordinary language does. It activates brain processes that have an evolutionary function, like ambiguity. And that's kind of interesting to think about. Why might ambiguity have an evolutionary function? Well, being able to toggle between alternate interpretations of visual data is a nice fallback position. Yes, it might be a lion coming to eat you. It might be something else, but it might be a lion, right? And having that fallback position, is this safe, is this dangerous, might be one or the other. In case the first sensory impression doesn't work out, you have a fallback. Poetry accomplishes this by linking primary sensory modes with more abstract ideas. And these things come across in very subtle forms: rhythm, cadence, and sound, as well as in sensory images. And we're going to study this together with a couple of quick poems. This one I want you to, does anyone know this poem? I'm hoping it's kind of new to you. It's absolutely beautiful. It's one of the most beautiful pieces of Middle English poetry. It's from the 14th century. When you were walking in, you were hearing music. You were hearing a musical setting at one point of this poem. It was transmitted in a manuscript with a little bit of musical notation. So I'm going to say it, and then I'm going to ask you to say it. Sound good? Full is in the frith, the fishes in the flood, and mon walks a wod. Much sorrow walk with, for best of bone and blood. Okay, you ready? We'll do it together. Full is in the frith, the fishes in the flood, and mon walks a wod. much sorrow ye walk with, for the best of bone and blood. It's really lovely to say, isn't it? It feels good in the mouth to say. What does it mean? Well, I'd love to talk about it at great length, but we're going to move on to Sonnet 73 in a second. But I will say, think about some of the effects that make this lovely. The spreading of the alliterative elements of the line, watch them as they go through the poem. Fools, frith, fishes, flood. Then a change in pattern when the alliterative unit moves to the end of the line. In that line, the speaker is announcing his difference from nature, right? The fowls are in the forest, the fishes are in the rivers or in the oceans, and I'm crazy. That's the disjunctive image, right? That's the thing that shifts. One of the things I love about this poem is it really isn't an image. It's very abstract, right? Fowls in the forest, yeah, what birds, which forest, what kind of a forest, deciduous, pine. We don't get any of that information because it's really not the point. The point is the linking of this rhythmic cadence with the central idea of his distance, the speaker's distance from nature, this more abstract idea. So then in the next line, much sorrow eat walk with, that movement of the alliterative unit to the end of the line is continued. But then notice the resolution aesthetically in the final line, for the best of bone and blood. A perfectly resolved iambic line with an alliterative element in each foot. It's really wonderful artistry. Now, expert reading, that is, really smart people like yourselves, there have been a lot of studies on what happens to expert readers when they read. The brain, when it gets to really complicated forms of language, complicated syntax, right, implied metaphors, especially when you're reading a novel and you're having to think about the motivations of characters. What is this person up to? What are they doing? You're getting information from the language, but you're constantly processing at other levels of abstraction. Well, the brain has to recruit from a really broad array of bihemispheric areas to pull this off. You get activation in the angular gyrus, Broca's and Wernicke's areas in both hemispheres, regions in the parietal lobe. Reading difficult text makes the brain light up. It's good for it. So, maximal cognitive load. We'll play this out in a reading of Shakespeare's Sonnet 73. And I want you to think, as we read the poem aloud, I want you to think about these questions. What are the central images in each quatrain? You're going to see, it's actually an enormously simple poem at one level. But then it's got really incredible complex subtlety in the way it articulates this primary theme. So what are the central images in each quatrain? What are the component parts? So what are they being compared, the images being compared? And what's the abstract idea that links these three images together? Anyone have a good reading voice? Want to try this out? I guess there's no microphone. I guess I'll do it. That time of year thou mayst in me behold, when yellow leaves, or none, or few, do hang upon those boughs which shake against the cold, bear ruined choirs where late the sweet birds sang. In me thou seest the twilight of such day, as after sunset fadeth in the west, which by and by black night doth take away, death's second self that seals up all in rest. In me thou seest the glowing of such fire, that on the ashes of his youth doth lie, as the deathbed whereon it must expire, consumed with that which it was nourished by. This thou perceivest, which makes thy love more strong, to love that well which thou must leave ere long. So what are the three principal images? We got three quatrains. Anyone come up with anything? Quatrain 1? It came by pretty fast, didn't it? Yellow leaves, no snow. What time of year are we in? Autumn, right? Near the end of autumn. That's kind of an interesting point. We'll come back to that in a second. So we have a tree near the end of autumn. We have the evening sky at twilight. Importantly, after the sun has fadeth in the west, right? And then quatrain 3, a glowing fire on the verge of going out. So here are our three images, right? This is the stuff of this poem is made up of. Now, here it is, rewritten. It's kind of weird, isn't it, to look at it this way? I'm sorry about the color there. I hope you can see this. I've kind of tried to highlight some of the patterns that you can run through this poem. You have the relationship between the speaker and that is the me that repeats, the in me in line 1, the in me in line 5, and the in me in line 9. The thou that he's talking to, convention dictates that this is a younger man to whom he has written the opening sonnets. But of course, we know intuitively as well that he has represented himself as older because he says, I'm on the verge of death and you're going to have to appreciate me before I'm gone, right? If we're going to say that's the theme of the poem, that's what we'd say, right? Appreciate those things that you're about to lose. To love that well which thou must leave ere long. Now, we'll go back to this. What makes Shakespeare, of course, is the way he articulates these complexities within the image. When yellow leaves, or none, or few do hang, right? What has he done to that image? It's a full tree in autumn. Then there's nothing on the branches at all. Then he puts a few back on, right? He reverses the temporal progress that we normally visually would associate with the falling of autumn leaves. Reverses it. So there's that's a cognitive itch. Why does he do that, right? Why does he change the process, right? Part of what this poem is doing is trying to make you linger. Trying to make you linger in the same way that he wants the speaker to linger. Hang on a little bit. Look a little bit more closely. Watch with me as I take you through the seasons of autumn. There's a haptic metaphor, a physical metaphor in there, which the boughs are shaking against the cold, right? That evokes the limbs, the shaking limbs of an older person, but it does so through the body and the experience of cold. It's a common sensory felt experience that if you linger on it for a second, you say, that's right, yeah, this is what happens. We get cold, and we can project our bodily sensation of cold onto these boughs. As after sunset, you notice he again, in terms of the temporal progression of the poem, he places us after sunset. He places us in processes, by and by, right? The overall effect, in other words, is to make you experience physically the lingering sensations that he then is going to link to this more abstract idea of appreciating that which is lingering. All right, now all of that is that's a simple kind of imagistic reading rooted in the form of the poem and how it unfolds. Now let's take it a little bit further by focusing just on the first quatrain and this phrase, bare ruined choirs. What is the bare ruined choir? Well, let's talk about the sensory components a little bit more. And we've done enough of this. We'll just move on. What do the choirs evoke in your mind? Do you think of choir stalls? This is what Shakespeare was thinking of. That is, a choir is the physical space in which the monastic choirs sang in the center of a church. And here's an image of them. I tried an image that I had taken from Norwich Cathedral, but it was too dark. It didn't show up well, so this is stock photo from the web. But they're often decorated with really elaborate wood sculptures, especially underneath the seats. They're called misericords. And you guys, during the slideshow, saw some of this imagery. You know, a guy drinking grapes. These are all from England. A centaur, a man wrestling a pig. But interestingly, birds, all over the place. This is one of the most common decorative motifs of the choir stalls in English churches. So when he writes bare ruined choirs, he wants his readers to think of the physical image of wood sculpture, which connects back to that tree branch with where the sweet birds sang. Now, why is this interesting? Well, aside from just being great poetry, like drawing on a cognitive experience that would have been common, there's also this historical context, the stripping of the altars. That Henry VIII dissolved the monasteries in 1536, and waves of Protestant reform swept through England. The Protestant iconoclasts particularly focused on the excess adornment of Catholic cathedrals and churches. Shakespeare's father, very famously, participated in the overpainting of murals in Stratford. It was just as a side note, this is the area I work in, is medieval murals. I take a lot of photos of medieval murals. And, 90% of them were destroyed in the 16th century as part of this wave of Protestant iconoclasm. And many choirs, though thankfully not all, were removed, or their sculptures were lopped off. That is, the choirs were left in place, but all the sculptures were chopped off. So, where Late the Sweet Bird Sang has three intertwined readings, none of which are reducible to the other. That first, we have actual birds whose summer songs have faded, right? Where late the sweet birds sang on the tree bough. We also have the sculptures and choir stalls recently destroyed by Protestant iconoclasts. And by association, the monks. That is, in this reading, the monks are those birds who used to sing sweetly from the monastic choir stalls before they were removed. So, big, deep question. Was Shakespeare, aside from reflecting on his own mortality, also reflecting on the demise of the old religion, appreciating some of its beauties, some of the things that it left behind, which still linger in his mental world despite their recent destruction? Talk about cognitive load. We're going to take it one step further. The actual first print edition of the Sonnets, 1609, printed during plague, speculation being Shakespeare never would have printed them except for the theaters had been closed and he needed money. So the 1609 Quarto edition of the Sonnets, there is the actual phrase as it appears in the text, bare ruined choirs with a Q. Now, choirs and choirs are homophones, and early modern spelling is notoriously variable. It's all over the map. But choir has a very specific bookish meaning, right? It means the gathering of book pages, right? So here's a whole nother layer of possibility. Was Shakespeare punning on this word to conjure an entirely different idea, where the yellow leaves evoke a written page? So, conclusion. Here, can I get a little light? Because I'm gonna have to read some notes for this. Thank you. This is where I get back on the soapbox. Evolutionarily, we get a rush from our encounters with the natural world. And they provide us with a certain form of pleasure. Art and literature provides a surrogate form of that pleasure, coupled with the massively important evolutionary aspect of allowing us to engage virtually with our social structures, as we saw Shakespeare doing. Our social encounters, however, are rife with incredibly complicated communicative systems, most of which operate at a non-conscious level. Literature attempts to make us conscious of them, to foreground the problems, tensions, and conflicts, and to stimulate our biological desire to resolve them to our advantage. We learn in a biologically safe environment how to navigate a complex world. And it begins with our first forays into literature as children, where we are soothed, where we are agitated, where we are cajoled, right? Where we are disciplined, where we're stimulated to pursue our curiosity, no matter what the risks are, where we explore new worlds, and then invent our own imaginative worlds through the powers of our creative brains. As we age, the problems get more complex, and the pleasure we take in solving a more complex problem grows. Great art and literature that transcends its time has this common trait. There are always new things to see and to say about them. They are hungry for attention, and we pay it, committing vast biological, social, and economic resources to developing and maintaining them. It is virtually the index of a healthy society that it maintains a robust imaginative world. Our brains like this activity, though our brains like other things as well, including high sugar, high salt foods. They provide us a pleasure that catapults us back to our most ancient biological structures of feeling and sensation. Despite the complexity and sophistication of our brains, their structural beauty, left untended by the discipline and nurturance of culture, those same brains are capable, as we all know, of horrific acts of brutality and psychopathic excess. Beauty inspires us to do better, to make ourselves better human beings, and difficult and disturbing art warns us of the consequences of doing worse. Recent advances in neuroscience teach us, above all else, the importance of tending to our brain's need for stimulus. The wrong patterns of culture, the cheap and momentarily satisfying experience of a highly stimulative verbal-visual environment, bad TV, bad film, the dark corners of the internet. These are the cultural equivalents of that bad fast food diet. To strengthen our neural selves, to navigate a complex world, we need the beauty of the brain to generate and then lovingly attend to the many diverse forms of beauty that the brain has projected into the world through the centuries. Thank you very much.
I have a couple of questions. First of all, 80% of people hold their babies on their left arm. the Madonna first picture in the middle, and then all the others left arm. Is there any correlation between holding your baby in the right arm and any abnormal development?
You know, I don't know that. I borrowed that study from this guy McGilchrist. Again, a book that Dean Comer, I can't remember where Dean is, but anyway, he recommended it to me. So I don't know. Does anyone know that, the answer to that? Whether there's, you know, the negative correlation of that same? Be interesting to know. I'll look it up.
The second question, in pediatric psychiatry, there's kind of a unwritten, well, there's some writing. The artistic kids have more mental health problems than those who are not artistic. Do you know why?
I don't know why. I don't. And Nancy Andreessen has written a fantastic book called The Creative Brain. She addresses that issue. She points to, in other words, she takes it beyond artistic children. She studies, her pool of artists is about 150. They're all contemporary. And she did the study over about a decade where she studied personality profiles of each of them and found a much, much, much higher incidence of depression in them. But I don't think in other words, that correlation's been there for a while, but I don't think it's understood exactly what the mechanism would be, right? And you know, I pointed out this synesthetes data 7 times. Artists and writers are 7 times more likely. But that, even in itself, that's not a particularly strong, that's kind of a curiosity and an interest, but it's not really a strong causative mechanism that's been described. Just kind of a rough correlation. Did you want to follow up, it seemed?
I just wondered if these are right brain people in a left brain world, and it's bound to be a problem.
Yeah, and that's McGilchrist's thesis. It's a fantastic book. It's called The Master and Its Emissary. And that is, in fact, his thesis, that creative types are kind of lost in a modern world that has shifted to a kind of overemphasized left brain world. It's an interesting book. I got huge problems with it historically, but I'm not smart enough to contest the science, but I am smart enough to contest the history. And I think the idea, I mean, Dean Comer mentioned this in the first talk of unfolding research on epigenetic changes at the genetic level, which is fascinating and extremely important stuff. It seems like his model, it can't possibly be right that would work itself out over the course of, say, 4 or 5 centuries. I just don't know how that model can account for, 200 and 250,000 year evolutionary histories. But it's very interesting. It's very provocative, and that is essentially his thesis, that a lot of depressed artists are, right hemisphere people in a left brain world.
Ashby, may I just put this on? Yeah.
May
I just ask a question?
Sure.
Or sort of make a little comment? When you were talking about reading and what it does for us and that kind of thing, I was thinking about one of those really famous reading scenes in antiquity when St. Augustine walked in and saw his teacher, St. Ambrose. St. Augustine was not a saint yet.
Reading silently.
Reading silently.
Yeah.
And the Romans just didn't read silently. They
Yeah.
didn't actually read for themselves much. They had somebody read to them.
Yeah.
And just sort of how physiologically different the effect must have been.
Yeah, and McGilchrist talks about that as well, because he thinks the demise of oral reading and oral recitation is part of this evolution of a left hemisphere dominated world, that silent reading tends to shut down that bihemispheric activation. And I mean, it's a fascinating topic historically in terms of research into medieval reading modes, because, of course, medieval monks continued to read aloud, but they were meditating. That is, the function of it for them was the actual spiritual uplift that came from repeating the words of the psalm, repeating the words of the liturgy. And then, of course, that was then connected directly to how they memorized things. They could memorize, hundreds and hundreds and hundreds of lines of poetry by connecting their reading with their physical environments. Many of you have probably been to Europe and been in cloisters. Monks walked around the cloisters and chanted as they walked. And the visual, some of the weirdest medieval cloister art has been revealed to have been primarily mnemonic. That the reason it's weird is that it gives a striking locational memory for the monk to attach visually to attach verbal information. And so that physical motion of walking around the cloisters repeatedly, chanting the words aloud, and then attaching them to visual benchmarks, they could then take that whole visual structure with them wherever they went. Right? They could go and sit in their bedroom and recreate the entire entity. So yeah, I mean, it's a famous scene that we probably skip over too quickly because it feels to us like progress for Augustine to have made this revelation. And it is progress for Augustine because it means he can pour through a lot more text much more efficiently, right? But another narrative would see it as a regress, right? That it channels you away from a different kind of more physical reading process. That's a great question.
I have two questions. One is, as a medievalist, what do you find is the transition point between what's referred to as the Dark Ages and what's the Renaissance? And then
what's the second question?
And then on the memory, Gregorian chants have always fascinated me. And do you think that that's also a mnemonic?
Yeah,
tool?
no question about it. Absolutely. And there's been some really interesting recent work on the Neum system of notating music and its connection to memorization processes. Just to give a really quick and blunt example, most people learn their music from their hand. They move the notes in a spiral process around their hand. And so we have in manuscripts really these incredible illustrations. They're very complicated, but once you decipher them, they kind of fall into line. And that's how people learn their notational systems. And Gregorian chants seem to have evolved out of multiple notes on a single finger being chanted at higher and higher pitch. And if I say any more, I will push way beyond my expertise. Actually, I already have, in just even saying what I said. But yeah, there is a relationship between the two. That first question, honestly, the further I get along in my work, the less I feel like I have a good answer to period questions. They've become less useful and less interesting for me. I used to have a big chip on my shoulder, never use the term Dark Ages, and never use the term Renaissance. The term itself is so heavily loaded because it implies a death, right? So as soon as you use it, you've implied the death of an entire culture. Anymore, I just talk centuries. It's a useful index to talk about the early and the high and the late Middle Ages rather than the Dark Ages. It's a useful index to talk about the Folkwanderung and the Germanic period in the early Middle Ages, and then the Latin period in the High Middle Ages. But yeah, so I'm gonna punt on that, on pinpointing a date, because I don't think it's particularly useful. The 12th century had a wonderful Renaissance, for example, a fantastic Renaissance. You saw the pictures of the Arabic optical treatises, which re-entered Europe via, so Aristotle re-entered Europe via Arabic translators. That all happened in the 12th century, and it was a fantastic period of creativity and explosion in new knowledge, a return to the classics. It had a lot of the features that we generally attribute to the later Italian Renaissance. So it's a bit of a punt, isn't it? But
I'm kind of interested to hear next week about how all of this works into the education part of it. I mean, because I teach classics and we read lots of Latin and Greek literature in translation on the page, but of course that's not the way it ever would have been taken in by the people who really used it. And I think it's a real loss to my students, actually. So
yeah, and you've told me quite a bit about the resurgence of oral Latin instruction, that there's a lot of great pedagogical innovation in using oral Latin as a more powerful sort of tool for getting students to master Latin.
Any more questions?
No other questions? You're taking it easy on me.
I'm wondering, you've not talked about music at all.
No, yeah.
It need be an obvious, very rich way to think
Yeah.
about this.
I know nothing about it. I mean,
Can you repeat the question?
he said you didn't say anything about music.
Oh, okay.
And I mean, of course, it's a very rich area. I just don't have any expertise in music at all. I mean, I literally in that 5-minute answer gave all that I know about Gregorian chants. So it's a very, very rich, very, very important area for crossing neuroscience, especially, and broader culture. I just don't. Do you?
Well, what interests me about it, just think about it, is what it suggests about evolution.
Yeah.
You talked about these phenomena, but now if we can think about how those phenomena change
Yeah.
over time, and how an artist, we think about an artist's view over the centuries. I suspect that these phenomena are not only very interesting, each one, but I think they morph, they're changing.
Yeah.
And you dramatically would see that in music.
Absolutely. Yeah. Yeah.
Ashby.
Oh, here it goes.
No, this
It was
is an
coming.
easy one. So we have this sort of gross characterization of left brain, right
Yeah.
brain. Is there, to your knowledge, a finer characterization where maybe a visual artist uses a certain part of the right brain, and a musician would use a different part of the right hemisphere?
I mean, I
Is it
immediately
that
thought
same
in answer to
question?
that question, McGilchrist has a great section on there have been really interesting studies of musicians because it turns out that most of us that are most of us, I won't project, there may be some professional musicians out there, but those of us who are not professional musicians, when we play music, we use our right hemisphere. But professional musicians use their left hemisphere. And so the fine-grained distinction is that the more proficient we get in whatever it is, whether it be reading, music, even visual art, we tend to shift over to the left brain, which processes more quickly and more automatically. And I'm probably, Dean Comer needs to stand up and correct any of that. I'm just speaking off of what I know. But this is all coming from McGilchrist's book, I should say as well. But it's an interesting phenomenon that movement from the right to the left seems to be where more of the fine-grained understanding of bihemispheric, and there he is.
Just to add real quickly that the left brain, right brain distinction isn't the whole story.
Right.
So for example, brain scans of artists when they're drawing compared to folks who are trying to draw but they're not skilled artists are engaging completely different parts of the brain.
Yeah.
We who are unschooled in art, we light up the back of the brain where we're doing visual processing because most likely we're so focused on the minutia of trying to create the lines and construct the picture. Trained professional artists, when they draw, it's very quiet in the back of the brain. It's the frontal cortex which lights up, which is where a lot more of your personality, higher level processing tends to be located. There's just an indication that what you put into a piece of art is very different depending on your level of training. There, the education to some extent, and also the ability to put in pieces that might be more imaginative. And so there is a popular culture idea that everything gets explained left to right, but Royce's question is a good one because overlying that, there's also other areas of comparison that are really equally important.
Yeah.
And there's so much going on in the right brain that when we simplify it to you do this on the right brain and that on the left brain, there's almost nothing you do that isn't a combination of the two sides of the brain.
Yeah.
And the trick in education is to help students engage both sides in the most optimal way.
Yeah, it's a heuristic. It's a convenient heuristic rather than being based on good science. But that has been a real revelation for me. This idea that of expertise and efficiency being a crucial mechanism that moves brain activation around, sort of. And again, I think it's as massively important educational implications. How we think about what people need when they're developing a skill, what they don't need once they've developed the skill, and what they might need once they've developed the skill. I think it's really, really important. Hi, Suzette.
I really appreciate Keith's question about music because to me there's that analytical side of music of making sure that the process is correct, of interpreting the music. But also there's that emotional side which really does give music the warmth and the feeling that communicates universal truths and ideas. So I'm wondering if we don't really use both hemispheres
Oh,
Or-
yeah.
And
Yeah.
again, relating to the question that that's simplistic and that you're using actually other parts of the brain to create that
Yeah. Yeah.
experience.
And to bring it back to what I know and what I've experienced so often in the classroom with students working on poetry is, again, if I had an fMRI machine, I would waste this $1 million a day machine studying how people read poems, because I really think something happens really radically different when you slow down on a poem, when you read circularly in a poem, when you break its structure into different parts and rearrange them. And I really think it does tap very different emotional responses the further you take that process. And again, when I say I know that and I feel it, I mean I feel it as a teacher and I feel it as someone who's studied this material a lot and still gets a charge every time I read Sonnet 73, right? I mean, that it doesn't lose that kind of, and I guess that's what I'm getting at is the comparison to musicians. They tell you, they played the piece over and over and over, but they never lose that tie to some emotional core that drives the performance. And I mean, I really feel that to be a human truth, and I want biology to catch up with that truth. I want neuroscience to come along and tell us why that's the case, rather than undermine that truth, which, maybe they will. Yeah.
Hello? Oh, I have one thing. Finally going to say something here.
Yeah, go ahead.
I've been a musician since I was about 9 years old, and the thing that's great about the way your brain works when you play music is you learn the piece, and eventually you think you know it, but you separate, because while you're performing, while you're playing, part of your brain is criticizing and coaching.
Yeah.
So it's actually I guess bipolar might not be the right term, but your brain is, I know it's communicating because I'm listening to myself while I play.
Yeah.
I'm another person doing that and helping and making it better.
Yeah.
And I guess that's just part of the brain process. I don't know if that's right, left, but I'm very conscious of it when I perform.
Well, again, I'm going to step over the line in my understanding of the brain, but Antonio Damasio's work has taught me to think more about bottom to top rather than left to right, and the sort of correlation between those deeper limbic midbrain areas and the higher regions. But and what you're describing, of course, is a very important, powerful experience a lot of us have in different parts of our lives, where that ability to attend consciously to what we're doing is a just hugely powerful biological mechanism for allowing us to adapt and change. And if you think back in our evolutionary history, how useful that tool would have been. And yet, we also like it when it turns off. We really like it, in fact, when we get past that conscious attention to the next state, which we know we can't get to without the previous one, where we can turn it off and have a full, complete, total giving over to the music or giving over to
The best thing about music is you're truly in the moment.
Yeah.
Because it's only that right there, and then
Yeah.
it's gone.
Yeah.
Unless you spend a lot of time listening to recordings and criticizing it.
Yeah.
I wanted to go back to the statement about the novice artist has activity posterior brain and the accomplished artist in the anterior. Does that imply that the novice, when they become expert, it changes, or are we just comparing two groups?
Well, we have seen those studies on reading, I know, and on music. So yes, they do change. On the visual arts, I'm not sure, Chris, if they have or not. But I mean, in the case of reading and in the case of music, yes, the studies show a shift as you gain expertise. And again, I'm not sure if that's the case with visual art or not, or if it's even been studied.
It wasn't done in that way. The implication is it might. We need more
Right.
studies to know.
Yeah, it's an implication rather than a defined result.
Okay. Based on what we know now about neurology and its role in the creative process, if we had either Shakespeare here today, or if we had CT scans back when he was alive, what would we have seen about his brain activity as he wrote Sonnet 73?
That's what I'd like to study. I mean, although what artist? I watched an incredible, you can YouTube this video, an incredible study on jazz improvisation, where these experimental designs are what really, as someone who doesn't do this at all, it's what I think the real creativity in science is in these experimental designs. They're really incredible. This guy designed a little small keyboard, and he stuffed jazz musicians inside of a fMRI machine, and he did improv with them from inside a room where they had headphones on and they could hear him and he could hear, they could exchange notes. So, and every one of the musicians that came out of that said, "Woo, it was a little weird. It took me about half an hour to really warm up to the whole thing, but then I got into it and then it got interesting." So anyway, I guess my point is stuffing Shakespeare into a fMRI machine as he wrote poems. I don't think the greatest poem would come out of an fMRI machine. What I'm interested in is reading, but even there, I mean, how much is it going to change your experience sitting there reading a poem, crammed up against a machine? I don't know. I mean, I don't know that these are things one can really study that well empirically, but, I don't know.
So nobody has put a poet in an fMRI machine to see
Not
what
that I know
happens?
of. Not that I know of. If I were to choose a poet, now that's an interesting, it would probably be Emily Dickinson. She did write, after all, "The brain is whiter than the sky," for heft them pound for pound, and they will differ as they do as syllable from sound.
That could present a research challenge, though, since she's not
Yeah.
around.
Yeah, everyone I study is long decomposed. So. Yeah, deconstructed by the earth.
More questions? Well, I think it's about time. Let's give him another round of applause.
Thank you.